you can drop the questions later. So I will call the next presenter. Is it Dr. Youcai Xiong here? Dr. Youcai?
Hello.
Okay.
Good to see you.
Yeah, sure. So you can start your presentation, please.
Okay, thank you. The speakers and the host. And my topic is okay, my topic is environmental risks of low density polyethylene and biodegradable plastic films in dryland agriculture. So in the northwestern China, the most of areas that belong to arid and semi-arid areas. And in most cases, the rain-fed agriculture dominated in this area. In this case, the application of plastic mulching technology have been widely used in northwestern China. So this the farming system, they have the significant outstanding advantages, and they use ridge and furrow with plastic mulching. So on the ridge surface is used to connect rainwater. So after that, the rainwater have been collected and stored in the furrows. So in the furrow, and the root zone of crops can get more water from the rainfall and get the better growth and green yield. So according to these photos, the no plastic mulching and the plastic mulching have a different performance for plant growth, because the plant, the maize plant can get the better water and the temperature. So hydrothermal conditions have been significantly improved as a result of plastic mulching. So the good harvest and zero harvest. So this is the very pronounced difference, can be easily to seen from this photo. On one hand, plastic mulching have caused a significant increase in green yield and the water use efficiency, and provide sufficient food production to local people. But however, the plastic residue have remained massively in soil depth. So in soil profiles, there's most of plastic materials with LDPE that can't be degraded. So instead of this, the facing such challenge, the biodegradable plastic mulching have been proposed and explored and widely used. But however, it stirs the questions: how is the environmental effects of such biodegradable mulching? So this is the serious pollution from plastic residue in soils and the environment of fields. So environmental impact of plastic mulching technology to cause the serious environment pollution. So biodegradable plastic mulching have been widely used as a solution to replace LDPE, the traditional films, to minimize plastic debris accumulation and pollution in agriculture ecosystems. So, however, it is unclear how is the effects of LDPE and PLA, that biodegradable, the film residues on soil aggregates, that is the key indicator of the soil quality and structures. How is the aging characteristics in soils? So we tested the hypothesis that the addition of LDPE and the biodegradable plastic residues to soils would have impacts on maize grain yield, and the WUE, they might be increased, but how is the degradation performance in soils? So it's unclear. So soil aggregates fractions of stability and soil aggregates associated quality should be considered. So we have checked the performance of plastic residues in the soil profile in the maize field. So we have the checked the 1 meter depth of soil profile to check is the status of plastic residue in the maize field. So we found that both the residues for both types of plastic films, and in the traditional LDPE and the biodegradable films. So we're surprised, and the residues is widely distributed along with the soil depth. On the other hand, we have checked the scanning electron microscopes, the SEM. So SEM, the pictures show that the new plastic of two types of films have a different degradation performance. And the biodegradables, of course, as respected, as imagined, the biodegradable, it is indeed degraded quickly, but however, it still they cause the more environmental pollution. So this result of 2 growing seasons observations. So on the left is before nanofields, and on the right is after nanofield. So according to the pictures as indicated, the effects of LDPE and PLA degradation from residues on soil aggregates in relation to the aging characteristics. So we're surprised the LDPE is very slow degraded. But however, biodegradable residues, of course, is degraded quickly, but it still causes the more serious destructions for the soil aggregates. So composition of soil aggregates, the micro aggregates, the proportions have been decreased the more rapidly, and decreased below but much more than the conventional plastic residue. So the above picture, the above part of pictures, they showed the process of soil aggregates degradations as affected by LDPE. At the bottom part of the pictures indicated the status and the results of the soil aggregates destructions. So this surprised the biodegradable, the plastic residue caused the more serious destructions, the negative effects on soil aggregates composition. So micro particles have been reduced, and micro, the particles of soil aggregates have increased. So that's the indication of soil quality decreasing. So the decreased the soil qualities have been resulted from the mulching by biodegradable the plastic films. So we have the drafted conclusions about this result, and then if we make comparisons between the two types of plastic films, so LDPE and the bioresidues have a different result for the soil quality, particularly for the soil aggregates, because aggregates is the key indicator of soil quality, is the physical chemical properties of soil quality. So this is easily can be seen from this picture, and the biomass productions is a little bit lower in biodegradable mulching than the LDPE conventional mulching, but still the cost is critically is caused the serious pollution and the destructions to soil structures. So we have the points have summarized from our research. The negative effects of a DPE residual forms on soil qualities and maize the productivities were higher than bioplastic films, but their adverse effects, negative effects on maize farmlands were similar. So residues, the film can affect soil aggregate structure and composition. And also residual films can change soil water storage and the soil structure. So we would find that both types of residues have brought out the similar negative effects on maize yield, WE, soil structure and soil aggregates, and the other the physical, chemical properties of soils. So increase the residues, improve the soil nitrogen level, and lower the carbon to nitrogen ratio significantly. Also, it decreased the biomass, carbon, and nitrogen levels, but with no significant change in C2N ratio. So maize yield and the WE decreased, while the water storage increased significantly. So this phenomenon of soil aggregate change is mainly resulted from the addition of residual films and microplastic, the films, plastic generated in the degradation process. So this is the main result for our research. So any questions, you're welcome. To the end of my presentation. So thanks the host for organizing such excellent the seminar. So we're benefited from these activities. So welcome all the speakers and organizers to visit Lanzhou University, Northwestern China. So this end of my presentation. So welcome any questions.
Thank you so much, Dr. Xiong, for the presentation. So we open Q&A. Q&A session. If you have any questions for Dr. Xiong.
Thanks very much, Dr. Youcai Xiong, for the valuable presentation.
So thank you.
Okay, thank you so much for the presentation. So if you have more questions, so you can drop in the chat box and Dr. Xiong